Okay, so let's try 13.3 number 5, for which I have 1 over 25 plus 1 over 125 plus 1 over 25 plus 1 over 5, and kind of so forth, continuing in this pattern until I get to 625. What is the pattern?
You're square rooting something, looks like?
No.
Times it by 5.
Yeah, you're multiplying by 5 to get from every step. You guys see that? So,
So that's R.
yeah, so the kind of ratio here, right, is multiply by 5, multiply by 5, multiply by 5, so forth. So, this certainly seems to fit into my usual geometric formula thing, but it's really weird, right? So, I would probably start by factoring out the first thing. Or maybe thinking in a different way. Maybe I'll think this way. So this is 5 to the negative third, right? You guys all with that? And then my next term is 5 to the negative 2, and my next term is 5 to the negative 1.
That's 5 to 0.
And then we're going to get some stuff. Okay, so they're 5 to the 0, 5 to the first, 5 to the second, 5 to the third.
And then 5 to the fourth, which
And
is that?
yeah, 625 is actually 5 to the fourth.
Interesting.
You guys see that? Okay, so now I just want to figure out how to add all this stuff together, right?
No,
Okay.
actually, we wanted to find out how to get
Yeah, I want the sum,
the
right?
number of terms without having to go all the way through that.
What?
To find the
It says find the sum of the series. Yeah. So there's the whole series for one thing. Which I really only did because it was short. I personally probably would have left the dot 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 in here, but you guys were psyched, so we kept going. Okay, so I would call this thing S, and then what's my trick for summing geometric series? What do?
You modify the thing so it matches the formula?
Okay, so one you could modify so it matches the formula. Yeah. No.
First four terms.
Multiply through by the ratio. So what's the R for this one?
5.
Yeah, we're multiplying by 5 every time. So I'm going to make a new S that I'm going to multiply by 5. So I'm going to get 5 times S right here. So what's 5 times S?
We got 1 over 1,000 plus 1 over, right?
What?
Because that'd be 1 to the, oh.
So I'm going to take this whole series, right? And I'm going to multiply each and every term by 5. So when I multiply 5 to the negative third times 5, I'll get 5 to the negative second, right? And then when I multiply 5 to the negative second by 5, I'm going to get 5 to the negative 1, which is why I did that, right? So that they'd be kind of matched. And then at the end here, what am I going to get?
5 to the 5th.
Yeah, I'm going to get a 5 to the 5th.
So we said.
And then I'm going to take this whole thing, right? And I'm going to subtract it off, right? And then this is going to cancel, and this is going to cancel, right? And all my 5s to powers are going to cancel except the first one, and I'll be subtracting that last one, right? So I'll get how many S's over here? You had 1, and then they took 5 away. So there's minus 4S over here. And that's equal to the first term, 5 to the negative third. Thank you, Ethan. Minus 5 to the 5th. Why is it minus? Yeah, because we were subtracting all of that, John. That's cool. So I got here, minus 4S is 5 to the minus third times minus 5 to the whatever. That thing. Yeah, good. So I gotta get the 4 out of there, right? So how do I get the 4 out of there? Yeah. divide both sides by -4, right? So that'll give you your sum is, you need to learn to write left-hand.
Negative
Okay,
5 over
so-
4 to the negative.
5 to the -3rd, oh shit,
That is a
sorry, first day with the left hand.
Oh.
Minus 5 to the 5th, all over -4.
Not bad.
Okay.
And that, ladies and gentlemen, is my answer.
The -4 negative sign is really adorable. No, 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 no. Aw. I had to say something.
What?
Cool. Question, Seals?
The computer's in the way.
Oh, the sign on the -4, which is it was like cockeyed.
Yeah, it was super wobbly because.
You don't have to even write any more steps if you see.
Yeah, some people get really good at eyeballing that telescope. I'm personally not one of them. I usually try to write it down. I have a tendency to drop one of those things in the telescope. Yeah, the telescope is this. That's these things collapsing together.
Mm.
Yes, it's just like a telescope when you put it away.
Mm.
Right, the only thing you're left seeing is the first thing and the last thing. Cool. Questions, Steele? That helped.
Yes, yes.
Yeah, so in general, that's the trick I use, is just like remember how the formula came into being. Don't try to use the formula.
Well, yesterday we used A sub n equals AR exponential n minus 1 to find the number of terms.
Find the number of terms. So yeah, one thing you could do is you could do the sum from n is 1 to n of a1 to the n minus 1 is what? R minus r to the capital N over 1 minus r. I think this is the formula we developed the other day. And in that case, this is, your r is 5, and your
A is,
a1 is 1 over 125, and your capital N is, well, that one you have to figure out how many terms there are.
before you can do that, okay.
Yeah, so I guess you would have to write this out to figure out how many terms there are, or you could notice that there are, well, 8.
Without the summation and the capital N and N equals 1, just take that off and write, no, I lost it.
You lost it.
I think this is the thing you need for a finite sum if you're going to use one of the formulas.
Okay,
And I think that should give you this, it will give you the same answer. Up to counting errors. Counting errors are the one that's most likely to occur, just trying to count how many terms there are. Oh, in fact, I just said there are 8.
yes.
Which there are.